You know the pain. You try to convince your colleagues to use your latest Grasshopper script with advanced integration with Notion or Supabase, but they simply do everything just in Excel. And the thing is, they're pretty good at it. Maybe Excel isn't the sexiest tool in the space, but it's certainly highly effective and widely used. And that's why computational designers need to master the interoperability between Grasshopper and Excel to better unlock the capacity and the experience of your senior colleagues and multiply your team value. Today we'll explore how to create and export data tables from your parametric BIM model using Pancake Spreadsheet. So for this we'll start with our lightweight parametric BIM model that we generated in the previous Elefront video. But before we dive in, my name is Marijn Luijmens, and on this channel I share strategies and insights that help to scale your Grasshopper workflows. So make sure to subscribe to improve your parametric modeling skills. Now let's get started. Alright, so here we have this model that we created in the previous Elefront video. And this model consists of blocks with all sorts of properties attached. So check out the previous videos and insights on how to actually create such a model. But assuming that we already baked it into Rhino using Elefront, we basically have this model with all sorts of properties. So for example, this is an exterior block that is positioned on the 18th floor, right? So as we go down, each block has a different property. Other properties are the same. This one is building 0, whereas this other building actually has the property of building 1. So the value is that now we have this model that we can easily dissect and create data tables from, which is exactly the purpose of this video. What we're doing in step 1 is we are essentially grabbing one of these layers, so one of these. And what we're essentially doing here is we're just detaching the attributes. So those are all these values, right? But then for the floor plates, so let's just see what we're doing here. Let's go to a floor plate. So essentially, these objects have these properties attached to them. So there's a floor space area. Then we also are able to differentiate by building and by story. The next step is to actually then deconstruct these Elefront attributes and for each of them create an association. Now you could also do it without, but I would heavily encourage to not only get Pancake Spreadsheet, but also to get Pancake, because everything here in the data organization is so valuable. This is probably my favorite section of Grasshopper components ever. So I will literally dedicate an entire video about this in the future. But for now, let's just focus on this component, key values to a SOC. The reason we need this is because Pancake Spreadsheet actually has a component that allows to set association to cells. Basically, each association is a row in the table, right? So we can actually use this component, a SOC to data table. This is a neat little trick. And then if we go to create data grid, this is actually a component from Lunchbox, but it's one-on-one compatible. And what I really like about this is that we're able to preview our table here. So yeah, as you can see, we basically have 2 columns here. So for each building 0, we have all the stories. And for each story, we then have the floor plate area in square meters, and the same for building 1, right? So it's quite common that you would want to calculate the GFA of your model, right? Now, what we're essentially doing here is a little bit of data processing to define ultimately the cell range, because Pancake needs to know which cells to actually paste our content. So we'll need to create a data spreadsheet first. So this is essentially the equivalent of a Excel workbook, which also requires a path, right? So we will need a file path, an extension, which in this case is .xlsx, which is the Excel format. And we'll just call it my workbook for now. So this is essentially what the path should look like. And then we're attaching this create spreadsheet component in which we have a sheet, which is called window schedule. Let's test it real quick. And voila, now we have a nice Excel sheet with our table. Now, what else can we do? Pancake has nice components to actually organize and categorize your data better. So for example, using categorize, we can actually combine properties with a certain key. So in this case, I want to group by story to reduce the amount of rows we have. So to show you what I mean, here we still have all the objects, right? So basically each row here represents one of these floors with their properties. So building 0, story 0. But what if I now would want to add together, let's say each story for both buildings. So for example, building 1 and building 0, just to name something. And then we would want to create the sum of the entire floor space area. So that's why we use the categorize component here. That basically allows to create a branch for each value of the key story. So at the end, we will have our updated data grid that actually has no longer the building identifier and only has 22 rows in this case, because that's the total amount of the stories that we have, where now we see the sum of both building areas combined. And then we just repeat the same steps and we're free to export it as we just did. All right, so in the next example, we are taking the windows in the same way, right? So we just select all the window instances. So here we get 650 reference blocks, each with a unique block name that we created in the previous video. And then we're deconstructing these attributes and we're taking all the keys and their values and transforming it into this associative array. So let's just say again, SOC2 data table, create grid, and let's review this real quick. So the windows have a bit more properties on them, so there are quite some rows. So in this case, you can imagine that we would just want to make a count of something, right? So instead of now exporting this directly, perhaps we want to do some manipulation and grouping first to save our colleagues from having to skim through 650 Excel lines. So how do we do that? In this case, we're going to take two values. I want to group in this case by name and by building, and we're going to use that to categorize. So in this case, I would want to group by name and by building. So I'm just joining them to use those as a sorting key. And what we then get is 77 branches that essentially groups the similarity for these two keys. This means that we can count all occurrences of a certain window frame with a certain name on a certain building. I could also use story, whatever I want to know, right? So in this case, I want to create a count, and I'm just using list item to grab the first object. And then I'm using list length to essentially count the instances of in each branch. So now we have a new updated data grid, right? Where we have only unique window names on each building. And then we can count how many times this window frame happens in building 0, which is 3 times. And then again, we're free to export and update our Excel. And now we have our Excel file with our windows and their respective count. So what if we just want to create multiple schedules all in one go? So in this case, I want to build 2 schedules at the same time. So we can use floor plate and window, and then we're using reference by layer. There you go. Update, detach attributes, Elefront attributes. We're going to deconstruct them like so. Then key values to a SOC. There you go. And now we have a deeper tree structure because now we have for each of these values a branch of objects, right? That we're then deconstructing. And what this component does, it actually creates a new branch for each object and it gives it a sub branch for each, right? If we then translate this into an association, we will have to shift path like so, which then shifts us back to 2 branches, one for floor plate, one for window. And I would like to wrap this as a list. So now we have 2 branches with 2 arrays, and I would like to actually merge them inside one association. So in this case, I'm going to flatten here because I just want to have one array object for each schedule that I intend to make. And then to make things easy, I will just give it the exact same name as the layer of all the objects I'm trying to put into the schedule. So this gives us one associative array that we can then inspect using the show SOC component. So I'll just click this button. So if we now inspect this association and we open up the tree viewer, we can actually see how we have an association with 2 objects, floor plate and window. We can then expand this and view all the objects in each of these arrays. All right, and then we can just use the snippet that we already have and we'll just connect it here. One important thing, we will have to graph this in order for these structures to match. Right, so I can now just connect this array here. Let's just move this over for a little bit. And then the sheets here. So if we now export, we actually have our Excel with 2 spreadsheets all at once. So let me know what you think. And if you have an idea for the next video, feel free to let me know in the comments.